Hello everyone, it's June 25th. All right, let's get into it. So the goal is we finish this first, which is today's challenge, and I'm gonna do the thing that we said we're gonna do today from yesterday. All right, let's see this one. Maximum points you can obtain from cards. You have several cards in a row. Each card has an associated number. The points are given in the integer array. In one step, you can take one card from the beginning or from the end, and you have to take exactly k cards. Your score is the sum of the points of the cards you have taken. Given the integer array and k, return the maximum score you can obtain. Seems to be one of those very classic problems. So for this one was to take the last three, right? For this one, let's take any two. Okay, so you can only take from the either side, right? From either side. What do you think? Well, what I think is flip it. We have encountered this type of problem for a few times, but flip it always works. So what I mean flip it is we have this, we just flip the entire thing to the right side. Then our problem is finding the maximum sum of the crossing subarray. All right, that's what it is. Actually, it's not even crossing subarray because the maximum is 3, right? So if I flip it, it's gonna be a window of 3. So like it's gonna be this, and then we just shift. It shall be it. Because if you flip it, and that's basically what it is, because you have to take this, or take this, or take this, or take this, whatever you do, you have to get something from this side, something from this side. Now, in the actual implementation, we don't have to flip, because we can use some trick, right? We can use some trick, so we can start. I was like start from this one, because I have 3, so we start from this one, and we find the sum of the last k values, and after that, we're going to shift right, just we ditch this, we get this, ditch this, get this, ditch this, get this, until on the left side we go. Okay. Let's see if that is the right thing to do. All right, so my ideal is we can say res is equal to sum card points the last k. Well, it should be minus k, right? Minus k. Once we're done, we can say for I, right? For I in range minus k to minus 1, actually to 0. So minus k to minus 1, we cannot get to 0, so we do that. And in fact, it's not going to be minus k because we already computed it, right? So it's actually going to be minus k plus 1, right? So for I from this, and then what we're going to do is this one plus k. Interesting. If it's minus 3 plus k is 0. So if it's minus k, that's minus k plus 1 plus k and be 1, so I have to minus 1. So what we do is we have to have a s, right? So S shall equal to S minus card points I minus 1, right? So we remove that, and plus card points I plus K minus 1. Is that correct? So if we start from minus K plus 1, I is minus K plus 1, minus K plus 1. So this is a 0. That is correct. So that's S. So we can say S plus equal to this minus this. And then res will equal to maximum, res, and S. And I'll return res. Oh, a lot. 9. Oh. 12. This is going to be 4. This one didn't really compute, so it'll be interesting to see if this one works. Oh, this one's taking all the cards. Very nice. Edge case for sure. And we're gonna do K equals, and then we say V dot 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 C. Okay, so if they do this, all right, and then we find this. We have card points in K, and replace this back in this max score. Actually, we have a couple more I can think of. For example, 1. Only take 1, answer shall be 1. Okay, so far so good. We can do one more thing, which is something I like to do all the time. Okay, and then remove some of the values. That's too much. This probably is too much. Add another one. Add another one there. Should be fine. Let's say we want 5. Pretty random. Okay, I think this one should be right. Oopsie doozy. It is not. I did it last time without error. The hell? What's the answer? 536. 536. What the hell? 1, 2, 3, 4, 5, 6, 7, 8. Ah, man. Did I not get every one of them? 1, 2, 3, 4, 5, 6, 7. Did I not get everyone? Could be a program error. Hold up. Oh, it does seem to be. So I has to go beyond. No? No. I have to take 0. It was a programming error. That was actually quite embarrassing that we had a programming error. Oopsie doodly, like it has to go all the way to the end. It didn't go all the way to the end. This one could have been avoided. Could have been avoided. I don't know why I was not thinking through in this one. Okay, take a look. Take a look. Is that 6 in the AM? What was I doing? one is 1423, right? 1423. And wrap around card points. Then we are looking for the largest sum of sub array of lines. Okay, it should be on. Actually, it's not on, it's actually okay. And then we do this. Oh, 639 is this time. No, this is last time. No, this is this time. I have 40 test cases. 40 test cases. How is it so much faster? We do this. We do this. We do this. We do this. This. This is the same thing. It's literally the same thing. Anyway, so done with this. Now let's go back to this problem from yesterday, and we're going to try to implement this. We have an idea, so we just need to turn this idea into code. Now, the idea I had yesterday is quite convoluted, so maybe by implementation we can think of something better. So my idea is we need to know, I need to write a function such that we'll be able to know, given the index. Honestly, it's not index, right? It's just a number. Given where the carpet is, then we should know the number of things inside. And the reason I choose to do that instead of keep track of everything, because if you keep track of everything, it's really hard to keep track, and then we're gonna jump a lot, right? We're gonna jump a lot. We're gonna have the end and here, right? So the first jump is always to take as much as you can, and then we're gonna jump here. Which just reminds me, why do you want to jump here? Because like you said, the best you can do is always hitting the end. Always hitting the end. That is always the case, right? We're always hitting the end. That is always getting the maximum. If you keep moving here, you're losing. You either stay the same or you're losing. So when you hit here, but you have more to hit. So always trying to get as much as you can, right? Because you keep going right, you either increase or you stay the same. If you hit this, so all you need to do is just put the end at here, put the end at here, and put the end at here, put the end at here, right? So that's all you need to do. So now the problem is further simplified. Now all we need to do is to know at the end, counting back k, what is the number of white tiles there. Now, how do we know that? Well, we'll always know the first one, because to give you, that's the first one. So you just do whatever, right? Whatever. Then you're going here, right? You're going here. And then what you can do is I'll compute, like this one I have 2. And then I know the gap, right? I know the gap. And then I know the previous, then you can compute how many is in between. Let's say I know how many is in between this, okay? Like I always know how many is in between. So the next one we're hitting here. Yeah, then how do we know where things are? So I do think we still need, with binary search, we will be able to know where the things are. Is it landing inside here or is it landing inside somewhere, right? We'll know. And we will know how much is here, and then we know, you know what, I feel like we still need that. We still need that. Let's do it. Let's do it. So first of all, I want to change tiles, right? I want to change tiles. How do I change tiles? We're going to say T's. How about that? Okay, we say for tiles we have a left. So what do we want? I want to know if it's a left or if it's a right. Right? That's what we want. Because if I land in something, then I know if it's a left or if it's a right. Okay? Then we also need hold on, let me give it more thought. We also need cumulative, the prefix sum, to quickly calculate in between how many tiles are there in between. So we need this. We need a pre-sum. Okay. And for L and R in tiles, all right, we say if not TS, then TS.append. We actually need to append two things. Okay, we need to append L and tell it it's 0, and TS.append R, tell it it's 1. This is if not TS. Else, if it is TS, then we check, right? We check. Else we say elif TS minus 1, 0, which is R, if this equals L minus 1. So we are talking about this situation, right? If they're the same, then not the same, not this situation. If TS minus 1, 0, which is 11, if that one is equal to L, which is 12 minus 1, if that's the case, then maybe it's easier I don't use tuple. This one I can change. Then we just say TS minus 1, 0, or equal to R. Else, actually, we just push these two. So we should say if TS and this, and else we just append those two things. Right? That's TS. Okay, now we say if not pre-sum, pre-sum dot append what? Append actually, I just realized it will be good to have a dummy value at the beginning, right? Because we have a dummy value at the beginning, I'll always be able to. So let's put a dummy value. What's the dummy value at the beginning? Well, the dummy value is, I don't know, minus 100, 0, minus 10, 0. Doesn't matter, some minus value. So like when you do binary search, you will always end in the right place. And then prefix sum will always be 0 and 0 at the beginning. Okay. Then we can just say if this, otherwise we do this, and if there's no if, and we will just append. So what do we append? So the first thing append, try to append the same value, because up until that is always the same. It's only when we will always have value in the end. Okay, so prefix sum dot append. We always append presum minus 1, and then presum dot append presum minus 1 plus r minus l plus 1. Okay, so this problem deserves this. We have to do it step by step. Have to do it step by step, and answer is 9. So what I'm doing right now is basically just copy and paste the test cases. So based on that, a little bit easier for us to see if the things we're doing make sense. And back. Maximum white tiles. All right, so what do we want? I want to see, I want to print TS. I want to print the presum. Just kind of take a look. Okay, TX, yes, 10 to 18. You see that? 10 to 18. 25, okay, that's good. And then, other thing is also good. So, if I have the binary search landing at some stuff, let's say binary search landing inside here. I know it's inside because I'm between 0 and 1. Then I just go to, right, I want to know, but I know this, so I need to go, so on the other side, I don't know, landing at anywhere. Oh, other side always going to landing on 1, right? That's the other side we're going to land on. So other side land on 1. I just want to know how many is in between. Now I know this, so to know how many in between is going to be this one and next one. So it'll be 0, 1, 2, 3, 4. No, 0, 1, 2, 3. So we find 3. 0, 1, 2, 3 is 5, right? And then the current landing spot for 5. So 0, 1, 2, 3, 4, 5. Wait, hold on, that's not right. 0, 1, 2, 3. 3 is 0, 1, 2, 3. Wait. Oh, shoot. I see what happens here. So if that's the case, oh my god. Okay. So, this is always needed, right? To push the left. Nope. No. If that is the same, then what we're going to do is the presum minus 1 shall plus equal to L minus plus 1. That's what we're going to do. So now I have 0, 1, 2, 0, 1, 2, 3, 4, 3. 0, 1, 2, 3 is still right. But for 5, become 14, right? So I say, I'm going to use this minus this, okay? We do that, we can get the number of tiles in between. So the 2 minus the number in between is 9. Which is 9. And then depending on where I land, I can add a bit more, or like if I land in between, if I'm at 10, that means we have nothing, and it's just if we're landing between, I can always use, the left and right doesn't really matter because these two are always the same. Okay, so now we have this. We can say what? 3, right? And then depending on how, we can always go 3. For I in range of 3, all the way to land TS, 2 at a time. Okay, so 0, 1, 2, 3, 4, 5. Right? So every time is this, and I don't know j. So we can say I shall equal to j minus k. Now minus carpet length. Is that right? Which means if I am at 18, minus 10 is 8. No, plus 1. Right, this is make more sense. We'll have the plus 1. Okay, so this I is the left. Then we're gonna binary search it. So from bisect import bisect left. Okay. So how do we just go index equal to bisect left. I'll throw TS to it. Okay. And I and key equals lambda tuple 0. Okay. What is that? So this will give me the index. Okay. So the index, what we need to see right now is if it's in between or if it's somewhere. All right. So if it's in between, basically it's this one, right? In between, basically is this one. So if it's this one, now hold on. This index is the index of here, right? So we will know. Let me think. What do we want to know? What we want to know is if it's between 0, 1 or between 1, 0. If it's between 0, 1, then we use that and plus. If it's between 1, 0, right, then we use that. We don't plus. Okay, so basically we say if TS index 1 is equal to 1. Okay, if TX index 1 is equal to 1, which means it's on the, we're landing between 0 and 1, right? We're landing between 0 and 1. Doesn't matter. Then we can say res, right? We can say res shall equal to maximum res and something. What is this something? That is going to be presum what? Presum J. And actually I made some mistake. This is not J. J is the index of these things. Okay? This is actually TSJ 0. That is what it is. Okay? That is what it is. So I probably shouldn't call it I. Make it confusing. Make like, because I and J usually are the same thing. Now J is indicating that I shall be. So the index and J, these two are on the same level. So I probably, let me put this as I, put this as index. Right, so index is, let's call it label. Let's call it label. I equals this and the label. And then we say if the txi 1 is equal to 1, then the presum, right, presum j minus presum I. But always minus presum I. If it's between 0 and 1, gonna minus this one. Which is fine because this one is the same, right? If in between these two, we minus this one as well. So we're gonna do this plus, because I'm landing in between, so I can say plus TS I 1 minus label. Okay? Minus label is the left. So we did this minus this plus 1. Because if it's 1, 2, 3, 3 minus 1 is 2, but we have actually 3 layers there. So that's 1. Else, which just means it's equal to 0, then we do the same thing. Except we don't add. There's no add because we are in between the gap. And then we're going to return rest. Alright, let's see if this one make any sense. We can run it. So we passed the first one, we failed the second one. That's interesting. We have 1, 1 and a 10, 11. Okay. Result is 3. That is very interesting. It deserves some investigation. Okay, so first things first, we're gonna check TS and check presum, see if them is correct. So TS is gonna be I forgot to sort it. In sorted tiles, sort doesn't matter because it's, yeah, it doesn't matter. You just sort it, that's fine. There's no overlap. Forgot. It's good test case. All right, so O and login, sort, O and login bisecond this. Okay, so it's O and login. Let's go. I want to test other situations. Just go for it. Maybe I should. All right, it's not right. It is not correct. It's not too big. Interesting. Probably some edge case I didn't consider. What did I do? Oh, I don't have a. What's the correct answer? 822. 822. Very, very interesting. So I sort it. And it still didn't work. I don't know. Might be able to debug this. Oh, it's not debuggable, huh? How? Let's see. I don't see any problem. Don't know. I don't know, honestly. Wait, hold on. TSI1? Shouldn't it be I0? Because it should be I0. Gotta be kidding me. If that is the reason, you gotta be kidding me. You gotta be kidding me if that's the reason. That was wrong. Oh my god. It was the reason. Now we passed. Why? Because my stupid head couldn't figure out this is supposed to be 0, 1. It's not 1. Oh my god. Could have done it one try. Imagine this is a contest. Imagine you're in a contest. It's a waste of time. Seriously, waste of time doing this. Alright, but we didn't do it very well. Look at this. Which means it's possible to do it even better. And so the trick is that we always want the carpet to land at the end of a set of tiles, because that is the only chance, right? That is the only chance, only time when we have we might be able to get to maximum coverage. All right? As the right side of the carpet moves away, right? Moves forward away from the end of a set of tiles, the total number of coverage either decreases or stays the same. As the carpet moves onto a new tile, the total coverage either increases or stays the same. Thus, the max happens when the carpet covers when the carpet reaches the end of a set of tiles. So now the question becomes how to calculate the number of tiles covered when we know that we know the exact position of the carpet. Now this method uses binary search to find where the left of the carpet is and use prefix sum to quickly compute the number of tiles covered. It is slow because we hit this, and this is O n log n. There's also hints that we might there should be an O1 solution, not O1 ON solution. So I think this is right. So the question is, how can we use another way instead of this to figure out where the things are? That is an interesting question. Can we, I mean, we have to sort. Anyway, oh, I don't want to see, I don't want to see, I don't want to see. I don't want to see. I want to just keep thinking. So we always at the end, all right? So the first one we can do. And the second one, can we just like keep track? If we can keep track, maybe we don't have to. Like we can keep track along the way. How many we have skipped, how many we have added. Okay, let me think. Just saying, it was go through this one by one. We have the first tile in, we do the computation, right? We know that, the first tile. And then move on to the second tile. I know total coverage, right? And, okay. And now I'll move on to the third tile. I know the total number. And then the third tile, I say it's going to move out of the first one. How do I know it's going to move out of the first one? Yeah, if we have a long tile and we have the binary search. Let's see. This is to put at the beginning. I'm going to put it at the end. So it's the same idea. And these are the gaps. Huh? Oh no, that's the whole thing. We have a partial. We have covered. Dragging here. It's the same problem that I have. Just keep track. They are keeping track of the end. I'm keeping. And they are going to the end. They're going at the starting point. think that's the same, the starting point, right? Because if you move right, you're always sacrificing. So it's either the same, or you're either on the right side. It's always, if the right side is stayed on the tile, then you move right, you're doing the same. And if the right side move off, you're decreasing. Okay, I give you that. Yes, so it's the same idea. But if you're every time you're jumping, so you're losing the same amount. The amount you lose, you know. And in my case, the amount you increase, you know. Then how do you calculate the amount you're gonna, in this case, how many, you lose these, you lose 2, right? How do you know how much you need to add? Well, you know how much you jump, right? So from this point, you need to jump that much, okay? You need to jump that much. And how do you know how many do you have? Now it's time to read the code. tj0 plus length, what's len? Oh, len is the carpet length. If this plus carpet length is larger than, what is I? I is from 0 rest is smaller than length. Rest is smaller than length. I didn't use that. We can terminate the search earlier if the result is equal to carpet length. If rest is equal to carpet length, then break. Let's see. This might be able to get it even faster. Might not, but it's worth a try. But still, we haven't figured it out yet. This is, what is J? Oh, I might know what this one is doing. Hold on. One step at a time. Let's do this one first. I hope we can make it slightly faster so we can exit earlier. Come on. Yeah, it is slightly faster. Still on the low side, but it is slightly faster. All right, so I think I know what he's doing. What he is saying is we have the initial, and we see if it's start, I think we have 2 pointers. One pointer is at the back. The other pointer is at the front. Okay? And then what we do is we compute current range and see if it's smaller than that. We move on. Okay, and compute again. If this is smaller than that, we move on. And now we find one again. Now it's larger than that. Okay. Now it's larger than that. It also depends if it's, it's like this or this, right? So if it's like this, completely outside, then it's completely outside. Then we'll move the whole thing forward. And I know how much it goes forward. And if it's inside, then we can. So we have multiple pointers. You can see that we have a pointer for the right side of the carpet. That's the label. We have the label. Okay? So we always know the label. The label moves forward. And we also have the tiles. Right? We have the tiles. So we have the left tile that's on and the right tile. Both are moving. Okay? And right tile will keep moving until it hits a point where the label is in between. Okay? So it's either in between or it's out. If it's in between, then we have one way to compute. If it's outside, then we have the previous one. And then, okay, when that's done, we move the left index forward. We'll compute a new thing for the right end. And then this one will just move forward one by one. So the right is always moving one by one. I see what this one is. I see what this one is. Wow, it's actually quite brilliant, the solution. Okay, so this is from it's similar, but its implementation is quite clean. So solution 1 says we must have the carpet land at the end of a tile, of a set of tile set. But it is also true that we must land the beginning of the carpet, the left of the carpet, and the left of the carpet at the start of a tile set. The logic is the same, right? But the benefit of this way of thinking is that the implementation can avoid binary search and the expansion of the original array. Keep one pointer going through tiles all the time at each step, right? At each step. If the right of the carpet hasn't been reached. Keep moving forward. Keep moving the pointer forward. Otherwise, we compute current length, right? Compute the current length and jump the carpet forward. And that's it. Implementation wise, we do need to sort it, right? So what we can say is tiles.sort key equals, now I don't have a key, we just sort, that's fine. And we have ij, so j in range, where the j is going to start at b. Oh, j should start at the same position, right? Should start at here, right? So j in range, land tiles, j is going to go to the end, and I, res equals I equals 0. I is the start, so I points to the tile where the left of the carpet is. Say j points to the tile set on the right. Okay, so every time I say if we need a s equal to 0 as well. I'll do this way just for fun. Okay, so when I say if tiles j, right, and what is the reach so far? The reach so far is tiles I 0 plus carpet length, right? Minus 1. So this is the right reach. If the right reach is larger than tiles, it's larger than the right tile, it means it covers the entire thing, then s plus equal to tiles j 1 minus tiles j 0 plus 1, right? And the rest equals max. That's s. Done. Keep going. Else, which means this one is smaller or equal to the right. Actually larger equal to. So now it's smaller than the right side. So it's either in between or we have gone beyond. Now, in fact, what I think is if it goes in between, okay? If it goes in between, we can do is this plus this minus this. So what I'm actually going to do is say the smaller equal to. So the right reach of the carpet is smaller equal to the right reach of the tile, right? So what we do is we're going to add the tile and we're going to minus what? Minus this is the reach minus tiles j1 minus the reach, okay, minus the reach. I believe I have the plus 1 as well because we are all talking about, well, hold on. So it's 1 to 3, right? So we add 3. If I'm at 1, and 3 minus 1 is 2. So I actually don't plus 1. And that's that. Okay, so that's that. Else is this whole thing is larger than. So the whole thing is out. So when s plus equal to tiles j1, we get the entire tile. In fact, we can do it here. So now if it's like this, right, it's a smaller. Hold on. If it's smaller or equal to that, if it's inside, we're going to do this. What if it's like this? Then I'm adding this, and I'm minus. Hold a sec. It only applies if it's in between. You know what? I don't like this because I think it also depends on the left. Or it could be entirely on the outside. If it's entirely on the outside, like boom, I'm entirely on the outside. Then in that case, I need to plus equal 1, right? If it's entirely on the outside. If it's entirely on the outside, or if it's here, then I need to move. Okay? Then I need to move. Hold on. If the right side is smaller, right? If the right side is larger than the right side of the tile, then we add a tile, okay? And then tile goes forward. If the right side of the tile is bigger than, then depends on the left side. Right? So we add this thing, and then we minus this towards this. What if it's like this? We add this and minus this. That doesn't make any sense. So I actually need another one. It has to be if tiles I0 plus line minus 1 is if it's larger equal to tiles J0, which means now we're in between. Then we can say S plus equal to tiles J, carpet right. Okay, so we can say CPR, then carpet right S plus equal to from carpet right minus tiles j 0 plus 1. So why don't we put these together? If the copyright is in between, if the copyright is larger than, nope. I was to just do it that way. Okay, let's see. Return. Doesn't seem right. Hold on. Oh, j never minus. See that? J never minus. S plus equal to this, right? And I need to do that. And then I plus equal, I need a minus. Where do I minus? Hold on. You know what? I feel I like to have 3 different scenarios. I think it works best for me if I do it 3 ways. So first way is this, right? That's the first way. But after that, I need to plus equal 1. Okay, that's fine. S minus equal to tiles I 1 minus tiles I 0. Okay, and then we do this. Almost there. Almost there. I see. Maybe I shall do this. Right? Get that. And then say S plus equal to this. S plus equal to this. Are you sure? What if I jump to the next one? It didn't come out completely. Hold on. If I'm landing in between, right? If I'm landing in between, Then we should move on the left, but we shouldn't move on the right. Yeah, that's what I think. Here's what I think. I'm going to say while j is smaller than len tiles. Okay, the right side, and if the right side is in between, if the right side is this, and if the right side is this. Yeah, you know what? Screw this. I'm gonna make it extremely simple. So if the right side is in between, then s plus equal to s. And then what you're gonna do is move forward. Okay, this is move forward, but we're not changing j yet. Right, Aleph CPR is smaller than tiles j0, so it's too small, right? It's too small. Then in that case, we do this. Basically, I move forward, right? We move the whole thing forward because the CPR hasn't even reached the other thing. Or if CPR is larger than the 1, in that case, s plus this, and then j plus equal 1. Wait, what happened? Oh, I can say j and the res is smaller, res is not equal to carpet length. List out of range. Hold on, I have one more. I need to do this, but this doesn't make any sense. Index out of range. I too big? How? How would that be possible? CPR is in between, right? If it's in between, then I need to move forward. Makes sense? If CPR is smaller than the left, then I need to move forward. Makes sense. CPR is larger than, then I record the current and the right move forward. So what happened? What happened? Let's print I and j. Let's take a look. For 0, 1, 2, 3, 4. So we are at 4 and 4. Oh, and the first one's actually not right. And the second one. Make sure they always. Okay, so we have to handle the accuracy. So it's not 0, 0, and then 0, 1. Okay. So there's 12. Or maybe we need to get S. Okay, so the first one is 5. Next one is 2. So because the first one, how is first one 5? What is J? J is here. Oh, so I add, okay, that's actually fine. Right, and then J plus E equals to 1, J plus E here. And now it's, I didn't change, right? So it's 10. So hit to 10. Now it's in between, so we do this, 10 minus 10, so plus 1. How is it 2? Hold on. CPR is the right limit. Is it currently is 1 plus 10 minus 1 is a 10, right? And 10, nope. 10 smaller, nope. So 10 is larger, so I add 5. Then J plus equal 1, okay? So I didn't change. I still the same. So I still have 10. But now we go to the first one. Yeah, now we go to the first one. And 10 minus 10 plus 1 is 1. So S shall be 6. Right? And then, so we are at the new one. So S immediately jump to where I am. So just let's delete the previous one, now in the line here. But I feel do you need a plus 1 here? Okay, it's getting closer. Shoot, all right. On 1. Hold on. Put initial in here. So we'll add 5. And then S will equal to 6. And 6 minus 5. 6 minus 5 is 1. 6 minus 5 is 1. Yeah, and then the 1 got double counted. We need to count. Hold on. Okay, we have 1, now we have 6. And after that, because I want to add the entire thing, so after that, I need to remove don't put this inside. But don't put it inside. Do it, remove it, move it forward, don't move J, and then start over. That makes more sense. Okay, this one looks promising. But slightly different from the actual one in the discussion. Oh, it should be right. Faster. Much faster. Because this is O and log n again. But much faster because we don't have to expand on the array. I'm going to leave it this way. I like how this one looks because it's very clear we have 3 different situations, right? We have in between, we have on the left, we have on the right, and each one has its own way of dealing with it. Sometimes you have to change S, sometimes you don't. You change afterwards. Okay, actually, these two are quite similar if you think about it. They're quite similar. Yeah, but I'll just keep it this way. Okay, good question, good problem. Yeah, I'm not going to study this thing. If a partial, I don't like it. I like how I do it. This makes more sense to me. Okay, that will be it for today. I'll see you guys tomorrow. Adios.